All right, that's my go signal. All right, yeah, as he said, I'm Keith Moore. There's actually supposed to be a cute little animation here, but don't worry about it. Okay, so my name is Keith Moore, as you probably figured out from us saying it about 3 or 4 times. I'm actually with HPE, that new company that formed from HP that, whatever. There's my handle if you ever want to send me an email. I am on Slack, but I forgot my idea, Antique Sounds or something like that. But you can get a hold of me there. This is actually going to be a fun one. I have to do this because I work for this company, so just bear with me. I may say some things by accident or on purpose about something that we might do, that we probably won't do, that we might do, and I'm not allowed to say that we're going to do. So that's what these are for, to say that don't take me at my word. Okay, so anyway, we'll talk about this thing called Borah. But this is really just a story. And it's a long story for me because I look like I'm the oldest guy in the room because I'm pretty close to being that. There's a few of us here competing for that honor. But basically, this has been a story of several years of effort, a lot of it my own personal effort, and a few of my friends from another company, and then these folks up in the front here who work with me. But it's a story of dubious distinction. It doesn't really need to be told, but you guys are the perfect audience for this. So when Joel asked me to talk about it, I thought, why don't I do this as a story about all the tears that I shed and the sweat that I've had, and a few times I actually got happy about a few things. You'll see in a few minutes. So really treat this as a story. You're not going to hear about React. You're not going to hear about Bower or anything else. There'll be a little bit of, there's some technical stuff in here, but this is really about a lot more work that has to get done to do some node work than you might expect. In order to do that, we're going to play a little game here. You guys are not allowed to play, the 4 of you, okay? Because you'll know the one that's a surprise here. But let's do this. Do any of you people know who these 2 guys are? And I'm guessing that you'll know some of these. Don't feel bad if you don't. And if you do, that's really cool. This is the second hardest one I'm going to show. Any guesses at all?
Hewlett and Packard.
There you go. That's who it is. It's Hewlett and Packard. Okay, now, that could have been just a logical guess, right? But there's actually a reason why I'm showing you these specific pictures. So this one's a little easier. Everybody knows who these guys are. Wow. You don't even have to say it. But here's the funniest part. I don't know if you can see it in the back. My favorite thing about this picture, I didn't really notice this until I clipped it out and put it on the screen. Look at Woz, and look at Steve. But look at Woz. What's he looking at? He's absolutely infatuated with those transistors. I mean, with those transformers, rather. I mean, he actually can't get his eyes off it. It's kind of funny. All right, who are these 2 guys? You should know them too, right? Yeah, it's Alan. It's Alan and Gates. And here's the other thing that happened to me. Just this morning when I was going through these slides to make sure they worked, I discovered this, and I want you to pay attention to that a little bit. I looked at the board. I thought this was pretty cool over here, too. He's got Apple and IBM and Tandy. Those were actually, at that time, those were his partners. They weren't his competitors at that time. And then look at this, 8086 and 68,000. That actually matters a lot to the rest of this talk, so just keep that in mind. Okay, the last one, hopefully this is a trick question. So these guys know who they are. And I'm guessing that you people probably don't know who these 2 are. Anybody? 1, 2, 3. Okay, so this is Tom Perkins over here. He just passed away about a year ago, right? I think it was about a year ago, 6 months ago. Yeah, not that long ago. And this is our hero. And this is going to be the hero of the rest of this story. This is Jimmy Trabig. So Jimmy actually started a big company up in the Silicon Valley called Tandem Computers. And we're going to talk a lot about Tandem here in the next few minutes. So all this stuff happened. The reason I picked those pictures specifically, those are from the era of the 70s, except for the Hewlett-Packard one. I cheated with those guys. That's from back in the 40s. But the other ones were from the 1970s, okay? So in the case of Microsoft, they were just starting out, and they were starting off as a software company, obviously. And Apple was just coming out with the Apple systems. And at the same time, the Valley was growing with a bunch of new startups, including this tandem company. And in '75, things were just about to change in the industry. And it wasn't just the industry, it's just the way we use computers. Just the way we use computers in general. So it's hard to believe this is not that long ago, really, at least in our old folks' eyes. This isn't that long ago. The stock markets were actually floor exchanges with real brokers. They still have them. I mean, it's not like they don't have brokers. I've been down there in the last few years. They still have the guys with little shirts and all that stuff. But for the most part, we don't do that anymore, right? We trade, and exchanges are done through electronic exchange. So back in '75, there were actually physical guys doing the floor exchanges. They held the papers, and then at the end of the day, they ran in and stuffed them into computers, and then that's how they did the transactions. So it's really a settlement function more than anything. They didn't have ATMs. It's hard to imagine a day where they didn't have ATMs, but there were days that we didn't have ATMs. Almost all retail transactions were cash, believe it or not. Now, there were credit cards, and most of us remember the credit cards where you actually had to do the little kachink and actually do an imprint. The very backup systems that we have today are still around, but for the most part, people used cash or check. And the credit companies that were out there, did you know that the biggest one was Diners Club? For a very, very long time, it was all Diners Club. They owned the market. Now we don't even talk about them. But then you had Visa, and MasterCharge was the first name for MasterCard. It was renamed and all that stuff. And we didn't have any internet. Okay. Wow, I'm living in the past. You think this is just a thing about the past, right? Well, anyway, this is interesting, though. By 1995, there was a huge compression in the industry. So just within a span of about 10 years, a whole bunch of companies went away. A whole bunch of them. And if you look at what's left today, I picked these out. There's actually a few more than this, and some of them are buried within other companies like we are. But the reason I mentioned this up here is that these are systems that were actually created in the '70s that are still around today. And they were around in the '80s. Obviously, we're going to talk a lot about the last one. Why would you care about this? Well, it's because we're everywhere and you don't even know it. Have you ever heard of us? Probably not. But every day you use our stuff. Every day, every one of you uses our stuff. If you use an ATM, almost for sure it's on our stuff. Almost for sure. If you use a phone, any of the major providers, and actually I think even some of the minor ones should be up there. What's the one I'm thinking of? Mobiletel or Cricket uses us. Jasper, yeah. So, but Verizon, AT&T. So if you turn your phone on, it's funny because cell phones are interesting in that we perceive of them as one way. They're like a toy to do stuff with. We do interactive stuff. We go on the web, all that stuff. But what do the phone companies think of? Their big thing is when you turn the phone on to know who you are so they can bill you. That's like the most important thing in the world of the phone company. So that's what we do. When you turn your phone on, we're the ones who it goes back through to the cell and says, hey, he's over here. He's on the north side of town. And by the way, it's this guy, it's his phone, and he's authorized to use it, and let's let him through. And if he roams, I have to know that, so I have to know whether or not I can continue billing at a certain rate, things like that. So that's called home location registry. We do that almost probably 90% of the market in the US. Actually, worldwide. The other thing that you do, so if, let's say you don't have a phone, you don't use an ATM, but you do use a credit card, if you touch a credit card swipe, it's almost 100% chance you touch at least one of our systems, usually 2 or 3. Because the payment has to go through and get cleared by somebody. We do all that business. So those of us sitting around here, actually, these are our customers, literally. I call them Visa, MasterCard, Discover, and then a bunch of payment providers that you never heard of on the second bullet there. And the last thing is, we do retail stores as well. So again, I mentioned point of sale swipes didn't exist back in the '70s, but now we just walk in and stick a chip reader in and we're done, right? We leave. So this little quote from one of our buddies at Home Depot. They're one of our big customers too. Now, this is not a sales, I'm not trying to give you a sales pitch. I just want to give you perspective on where there are systems like this around the world that you've never heard of. And they're not running Windows and they're not running Linux. In '75, that Jimmy Trabig guy and a couple other people designed a system that was fault tolerant. That was their goal. They said, you know, these IBM mainframes are pretty cool. He came from HP, by the way. So he was an HP guy, and within HP, he was trying to promote the idea of doing a fault tolerant system. And they said, you know, sort of naff off. You don't know what you're doing, kid. Just get out of here. So he formed a company and actually built a computer that had no single point of failure, that was software and hardware fault tolerant, hot swap on the fly, and by accident, they got a couple other features we'll talk about later on. And this is basically the patent diagram. This is a later patent, actually, for something else, but it still fits the model. And actually, if you look at that architecture, it's kind of wacky, isn't it? I mean, even today, that's not what most systems look like, an individual system, that is. Now, if you looked at the internet, you pretended this was an Ethernet connection. By the way, Ethernet didn't exist, so this was just a wire bus. And he actually interconnected CPUs, and that way they could intercommunicate and fail over with each other. A very, very sophisticated system in its day. That was 1975-ish. I just put that number, you know, close enough. Everybody with me? All right, so how does it work? I promise you we're going to talk about JavaScript. I promise you. Anyway, NonStop is a special kind of system, and it still runs this way today. There's a thing called Guardian, so yay, go Guardian, go Guardian. I love that when I heard I was coming out here to see a place and it was going to be Go Guardian, I was like, oh, this is awesome, because we live and die by Guardian in our systems. But that's actually the operating system name, and it's always on, like I said, never goes down. And it runs as a single system image. What we mean by that is that we actually have multiple processors linked together, like an internet kind of connection, like it could be a bunch of Linux systems, as if they actually had a single system perception across all the different Linux instances. So if you've ever done that with Linux, which you can do, obviously, that's the way this operating system works, as a true single system image. So we can have up to 4,000 processors talking to each other, in theory. We don't usually do that, but we could. It's shared nothing, which was really, really unique in its day. So if I go back, these entities down here represent controllers of things like disk drives. Back in the old days, actually what's really cool is this is supposed to be a tape drive, believe it or not. That's a tape drive. That's a line printer, LP. Card reader, CR. Remember those little Halloranth cards? And then disk drive controller. So there's a mirrored disk drive down here too. But basically the idea is that these things are redundant and actually allow you to get from anywhere to anywhere. And so when I say that it's shared nothing, that's what I'm talking about. None of these things are shared, but everything's accessible from anywhere. So if you want to get from here to there, you can get there through a path, right? But you don't have to share anything. That's really important. We're going to talk about that later on. I already mentioned that you can have 2,000 to 4,000 of those processors, and it had built-in Byzantine fault tolerance. How many of you worked with Linux systems clustered and tried to do Byzantine fault checking and stuff like that? It's tough to do. So that was built into the operating system. And then it was also designed sort of as an afterthought because it had linear scalability. They figured out a whole bunch of queuing theory stuff. So there's some tools that sit on top of it that allow you to do queuing, which is really cool too. But we aren't going to have time to talk about that. We'll do that over beers. Then what happened was, so that's what was in 1970s, 80s. Around in the 1990s, a cool thing happened to us that really kind of sucked, actually. Proprietary systems got really taboo. You think they're bad now. During the 80s, what happened was all the telcos were pushing towards Unix. This is before Linux existed. And so a lot of the companies, including ourselves, had to come up with a way to act like a Unix system. So the standard at the time was POSIX. So we actually created an environment that allowed you to look just like a POSIX system. So basically Unix file system. So we actually finally had a way of referring to our files like you're used to seeing in your world with Linux and such, where you actually had slash directory. We didn't have that in the old Guardian space. We actually could support regular shells and POSIX commands. So we actually could do, change directory and simple stuff like that, which we couldn't do before. And then we supported a whole bunch of POSIX APIs so you could get into the operating system. And the way we did this was actually pretty cool because we didn't say you had to run either or. You could always do both. So in all instances, both environments are available all the time. Now this is the way we run our systems even today. So our systems today have both of these personalities. And just for you people, because I probably will slip later on, we refer to Guardian as if it's the separate thing from the OSS, but it's really not. They're both the same. Everybody with me? I'm not going to go over this slide. I put this in the deck so that y'all can have it if I do slides afterward. But it allows you to look at how the whole thing fits together. Basically, the kernel is at the top, and it works its way down. All right. Ooh, that screwed up. Well, that's OK. That probably won't be the last time that happens, but these probably shouldn't be there. Anyway, legacy is not always so good. What happened was, over time, the world moved on, and we're still sitting in the 70s world with Guardian, and we had to make some changes. We made the OSS change I mentioned a minute ago. But we had to make movements towards fundamental tools and tool sets that actually helped us going forward. And one of the things that isn't showing here that's really cool that we promised our customers, and it's still true today, if you wrote a piece of code that was executable in 1975, if you pick that object file up and you move it to our latest system, and I'm going to show you how there's a trajectory of systems that are pretty big list, you can still run it without changing it. Nobody else can do that. Trust me. I don't know. You know of any, I don't think anybody else can do that. So object code compatibility from 1975 to 2017 is still available in our system. That's amazing. But that makes it a pain in the ass for us because it's the legacy stuff's hard to maintain. So here's some of the stuff we didn't have that causes all kinds of issues. And we're getting to the point where I'm going to talk to you about Node here in a minute. Shared memory. The rest of the world went with SMP. So most of you have all worked with your little systems, even your laptops, right? Where you're actually running multi-core and you're actually sharing memory or splitting the memory up and using it separately. But basically, most systems were designed in the 80s to be symmetric multiprocessor. And I could give you a whole lecture just on that. But we're not. Our execution environment is really odd. And that's because of that darn diagram I showed you before, because everything has to handshake and all our processes talk to each other, and the operating system always knows what's going on, and the guy next to him, and the guy next to him, and the guy next to him. We have this thing called a poison pill that we shoot at each other, and all kinds of crazy things that go on. So our environment for execution is very strange. This is incredibly important for the rest of the talk. Our compilers are funky. Now, they actually are funky in the sense that they have to support ROS. They're not funky in the sense that they behave any differently than any other compiler. In other words, they're optimized. They actually have optimization levels. They have all the same things you'd have on any other chipset. But when you create an object file, it's totally different than anybody else's object file. So we have some issues there. We didn't have Git. Can you imagine your life without Git? I mean, I have a hard time, but I have to live with it. So I'm kind of used to it. We sort of have it now. It's a long story. If you want me to come back, I'll talk just about Git, because that's another real pain in my butt. We didn't have Node.js, but I fixed that. And we still don't have a standard package tool. We don't have RPM on our system. We don't have anything. So that's very frustrating as well. So as you can tell, I'm a crybaby about it. I bitch all the time to my managers about it, but what am I going to do? All right, that's the background. I promised I'd get to the JavaScript stuff eventually. So I'm going to tell you my little love story with JavaScript and Node.js. Now you have to remember, I worked for NonStop for a long time. How am I doing for time, by the way? I know I've only got a half hour, so I don't know how I'm doing for time. I tend to always go over, so if it's like we got 15 minutes, okay, good. 15 minutes is fine. Anyway, I actually fell in love with JavaScript, but sort of indirectly through another mechanism, but I'm going to tell you the real details here in the next slide. I actually left Tandem NonStop for a little while, and I went to Sun. And then when I left Sun, I came back to Tandem again, and guess what? I left again. I'm really flighty. But anyway, when I left for a little startup company, the startup company was a bunch of friends that I had that worked at Netscape. So needless to say, these people were interesting JavaScript people in the sense that they were the browser-side JavaScript people. So I sort of got into it then, and then I just left it on the vine for about 10 years. And then this happened. Now, this is an inside joke with these 4 guys. Justin knows what this is. That's not a Cupid. He knows what it is. I had a project that I worked on for a while. It was for about a year or so, called Guardian Angel. It was a play on the Guardian thing. So that's a Guardian Angel. He's supposed to be dancing around up there. And it just so happened that it was at the same time that this occurred. So how many of you remember this logo? Now, I know some of you remember this. It's not that long ago. So, well, we acquired Palm. We, as an HP, acquired Palm. And I was also working on this project, and I was like the biggest zealot ever for Webos. It's sad, isn't it? Isn't that sad? It's truly sad. However, you guys should rejoice because it did influence us in a positive way. So when we bought Palm, Palm had already been working on Webos. We rebranded it, blah, 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 blah. You know that kind of history of what happened with the tablets and all that stuff. But what was cool about Webos that you might not know is that inside Webos, the whole friggin' thing was JavaScript. Almost the whole OS. I mean, there were kind of little teeny kernel things, but I swear the first thing I did was boot this little teeny micro Linux kernel, and then everything else is in JS. So I opened that thing up, and I got pretty good. I actually wrote quite a bit of software for Webos. What a waste of time that was, right? But I got exposed to it. And then the second thing that happened, so I must have turned this on. The second thing that happened was that I actually found out that Node existed in this thing. Okay, so they actually had ported a version of Node to the Webos environment, and you could run it as a server-side JavaScript thing. Now, I'd never seen this before. Okay, so remember, I come from the Netscape side, so I'm a browser guy. Whoa, this is pretty cool. I can write JavaScript on this little client. And then I realized it's way cooler than that, because now I can make this thing a server, but it's the little thing in my hand. Now, you guys are used to this now, right? Because you design apps and React and stuff, and so sometimes I'm a client, sometimes a server, whatever. You know, I'm requesting, I'm receiving, right? But I thought this was the coolest thing in the world. And the other thing that happened to me, that same thing, was I had this Linux guy, because it was a multi-operating system demo. We had the NonStop was doing this big transaction. I think we were doing Pet Store. Were we doing Pet Store? Yeah, so it was a Pet Store variant. So we were the store, and then there's the client doing this other thing. And there was a very cool little twist off that we did to another cool database. I won't get into all that. But when the guy who was helping us from this other company came up, he typed in git whatever the URL was. And I went, what? Yeah, you just loaded a whole bunch of code. How the hell did you do that? So that was the second thing that happened. So 2 exciting things happened in that time frame of 2010. I learned about Node, and I learned about Git. And it was like, I didn't get my hair back, but it was almost that good. So anyway, here's one of the reasons I liked it for NonStop. So then I thought about it. That's what the little floating beer and the floating bacon was like. Ooh, I have all these great ideas. I could do this and this and this. These guys are used to this. This is, oh, there's Keith. Just send them off and give them some cookies and shut them up. So one of the things I was thinking, though, was I go, well, you know, this is kind of cool, because when you look at Node, this is the model that we were used to being just bashing our heads against. Threads, give me a thread, give me another thread, give me another thread, which sucks on our platform, because we don't look at it that. We look at it the way Node looks at it, which is, give me a request, I'll service it. Give me a request, I service it. I need more nodes, give me another node, I'll service it, right? Isn't that how we look at it? So I'm thinking, this is awesome. It's a non-blocking event. It's single event processing system. Totally context-free if you design it right. We're big into context-free on NonStop, by the way. You can scale it via replicated instances. In other words, if I need more node, I just create more of them. And this one tool, I don't know why I stuck this down there, but I love this tool. So one tool allows you all sorts of capabilities. All right, so that was my excitement. You think I'm excited now. A couple years later, or about a year later, I guess it says. Remember I said in the title something about Vegemite? We're finally there. A year had passed and Webos was dead, so I was done crying. It had been a year, I was okay, I was recovered. It took me about a year to wipe off the tears. So I thought, well, you know, it can't be that hard to port Node.js to NonStop, although I did know that a lot of other times I'd failed. Any of you know what mono, you guys know what mono is, right? Yeah, so I tried to port mono and about killed myself. But actually we could have done it, we just didn't have a customer. But we actually ported mono, so I thought, well, it couldn't be worse than mono. And then I had some friends in Australia. They were okay friends before I started, and now they're really close friends because we really went through a lot of hell. And we started to begin the port of Node.js to NonStop. So this is in 2012. 2012, what year is it now? 2017, all right? So it's been a while. And when we had this first call, I'll never forget this call. You know how it is funny when you have these team meetings, you've been talking for a while, go, well, we should really have a project name for this. And so I said, I think this could either be a tasty treat or a wretched goo, depending on who's eating it and whether it's working or not. And so there you go. It's Vegemite. If you've ever had Vegemite, it's either a horrible thing or tasty, depending on who you are. Here's that picture again. Oh, I know what those are. This was going to be important. It's supposed to be a little arrow that goes up and curves. And it's probably a good place to explain it here too now. I'll forget about the picture, I'll try to talk through it. So anyway, here's where it gets interesting. So as we started to look at the port, we had this dilemma that I didn't even realize was a dilemma until we started. It turns out that Node.js was available. Now this is 2012, remember. So how long, you guys have been using the Node.js for at least that long, at least some of you have, I'm sure. And you remember there's like the .9 release, .10 release, whatever the heck they were. Before we finally got cleaned up last year, it was like really a nightmare. So anyway, I didn't know anything about this stuff, so I go out on the internet, and I take a look, and I go, okay, I think we can grab a stable release, stable in air quotes. And then the other thing was we found out that there was actually an active version for Titanium. So now what these pictures were supposed to represent is this other nightmare of being an old technology. To maintain that object code that I was talking about, we've actually originally had our own custom chips way back in the 70s. Then we converted to RISC chips, which ended up being MIPS, if you're familiar with MIPS and ABI and all that stuff. Then they started to work on moving a port to alpha. Do you remember alpha chips? Now we're going to start getting in the range where you might start nodding your heads, right? And then Titanium, which is PA RISC. So remember when we got bought by HP, then they go, oh, you can't do this old crappy alpha. Let's do the new Titanium. So anyway, we had ported to there was a version of Node.js that was written for Titanium, but not our operating system. Key difference. And then out here, which you can't see, which is the current technology, it's x86, x64. I'll have a slide on that later on. But the reason those are up there is that, don't forget, we had to maintain object code compatibility going forward. Well, thankfully, with Node.js, that's not a problem. If we ever get Node running, it is compatible going forward. But for everything else, we had to worry about this chipset conversion. And we had to pick a place to start with. And x86 wasn't out yet. So that last bullet that's off the screen here wasn't out yet. So I talked with the guys, and we found that an old version of Titanium might be viable to do a test. So that's what that first bullet is there. Because we had to find something we could say, well, it's either going to work or it's not. Let's shoot ourselves or go on. So we picked this Titanium chip. And I was very concerned that the VM itself was going to be a problem. That was experience from our Java VM, which I love and hate, and also the experience I had with the Microsoft one. So anyway, we decided we'd go for we'd pick a generation that was stable. So it was, I think I'll tell you later on what version it was, and blah, 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 blah. Okay. So once we get it, then I said, we're only going to do x64 going forward. Did we have any problems? Oh my God. We had lots of problems. Well, there were some issues with the way the virtual machine launches. So this is a chronic problem when you're dealing with these object files. I won't get into the gory details. Again, you can ask me over beer. But basically, the way we do our object file execution is very odd when we start up. and most systems can't deal with it. So we have to write our way around that. So that was kind of an issue. So that's basically your bootstrap kind of thing when you start one up. This was the biggest one. Compiler compatibility was an issue. We have our own compilers, our own linkers, and I can't remember. I think it was, I know that the new one's written in, but I think the old V8 was written in C++, but I don't know what version, or was it in C? It was C++, right? Yeah. Have you guys compiled Node at all? Yeah. So we had some issues with the compiler as a linker, and then this is the number one problem, still is today. I literally lose sleep over this. Never-ending nightmares, if you get the joke. It is unbelievable the issues we have ending this. I'll tell you about in a minute why. And then another couple little issues with library compatibilities, but those weren't as big a deal. So after 3 months, we sort of got a Node.js running. And I was so excited because I was sort of like the project manager. So I'm kind of like that dick that sits in there and goes, are you guys done? Are you guys done? Are you guys done? So at some point they said, yeah, I got it to run. It comes up, and I run my little test script, and it works fine. And I went, oh, this rocks. Now, you have to realize there's just sort of pent-up energy. It'd be like if you guys were sitting there waiting for the next release of Node because you wanted this one feature, and you'd like all of a sudden they go, go! And then you find out that, oh, NPM doesn't work or something. Well, that's literally what happened to me. Literally, I didn't have NPM. So I actually ran the thing and ran their script, and it worked. Oh, this is exciting. So then I just went out and pulled a bunch of scripts over from the internet and tried to run them. They all blew up. It was awful. And then I said, well, what about NPM? He goes, well, you wanted us to do that too. Well, yeah, obviously. So I had no libraries, and I had no way to get libraries, so that was kind of a pain. But they were great. We got that done. Actually, I did help with that, so at least I finally added some value. And then we started to move the x86 port. So we thought, well, if it worked on Itanium, and all we had to do is flip around with the endianness a little bit, it should be fine. Now, let me make a little note here. When I say we had to play with endianness, for the Itanium, we actually didn't. All we had to do was flip bits sometimes when we went out and played with data. What I didn't realize was when we went to x86, we flipped back to little endian, and NonStop is big endian. So now I've got, are you guys aware of how, I'm sure some of you are, of how Node works and everything? So the V8 engine itself is sort of like gold, and you want it to actually run. It is a virtual machine. You want it to run left alone. So when it compiles into that machine and executes, those bit flips are done by the VM. You better not be mucking with it. So we had to go in and out of the system, the x86 system, and flip the bits every time we went into Node and back out. But only sometimes, because sometimes the Node system will do some of that manipulation for you and put you back into V8, so you don't want to do it twice. It's very, very odd. The other thing that happened was, once we get outside the Node system, we have to make sure we're flipped yet again, because our data space isn't always flipped big endian. It's sometimes just little endian, so it is really a pain. Fortunately, our lovely compiler developers built a thing to accommodate us. So when we compile on x86, we can actually turn a little flag that says, this little bugger is big endian, and it flips all the bits for us as we're coming in and out of registers, which you'd think would be really nice, but it's not if you're playing with the bits inside the VM. So we had to turn that off and do it all manually. Oh, and then there's this last one. Can you guys see it the way in the back? Probably not. LibUV. Do you guys aware that it uses LibUV too? So, or LibUV, as they say in Australia. It is really not compatible with NonStop, and that has to do with the fact that we have our own IP stack and all that kind of stuff. So that's been a bit of a pain. 6 months later, we had something that worked. We exposed a couple other issues with SSL, blah, 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 blah. And in 2014, we actually demonstrated it at a show. Yay, we're done. No, we weren't done. Anyway, if you wondered what a Borah is, there it is. There's what it means. So now you know why this thing is titled this way. And now I'm probably running over, and I have just a couple more minutes here. In 2016, our guys internally at HP go, hey, you know, Tandem's pretty cool. Maybe we could run Node on a Tandem. And then we said, well, yeah, you could. We have one, but it's running version dot blah, da, 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 and they didn't like that. So they said, why don't you give us a newer version? So we're working on a newer version right now. And thankfully, those of you who follow the releases, I was so happy that it actually became formalized. What was it last fall? Almost a year ago. Was it last fall? Yeah, when they started the formal releases. So now we picked up, and we're going to do even releases. I'll try to scoot by these here real quick. So there's what we did originally. This is the V8 engine, and this is obviously a Node version. And then we're doing 6.3.1 right now. There's actually a stall point right now. Believe it or not, we're waiting for our compiler to get done. So it's really amazing. Because Node.js, or V8 actually uses C++ V11, and believe it or not, we didn't have V11 yet. Things just kind of move slowly on our platform. But we're fixing that up. That's almost done. And we're going to go forward and always stick with the even release, which just makes sense for somebody like us. All right, lastly, I'm just going to mention this because this is interesting for us, because going forward, this is why I think there'll be some traction in this space. So remember that picture that was real simple, had little boxes, doop, 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 and then the little controller, and then the disk drives and all that stuff? Well, that's grown up big time. It doesn't look like that anymore. I didn't show you the intermediary position. But what we're doing is now we're actually virtualizing our OS. So we'll actually be able to run with OpenStack and instantiate our OS, which we think is going to be quite powerful. Because now you'll be able to run in one of these little, what we call CPUs, are basically, they look like instances of Linux that are linked together, but they know each other, they're friends. So you'll be able to instantiate multiple systems of nodes, multiple node instances, under one controller, because we have this really cool software that does that. And it'll all be done under OpenStack. So we're not real keen on containers yet within our operating system, but we perceive that eventually we will have container systems that allow you to launch those up. And so you'll be able to do it just like you would on Linux, except it'll always stay up forever and ever and ever, which is what we do for a living. I think, yeah, that's what I just said. That's all I have. I don't know how much over I ran, but hopefully. Was that fun? Thank you.